Hi, welcome to the ShiCoMath lab. And this is our polar coordinates lecture series. And this is the part 4 about this series. And in this video, in this part, I'm going to use 2 videos to talk about how to find the area bounded by the polar equations. So the first video will be the simple one, just basically they give you polar equations and then how do you find the area. The second video will be will be a little bit more complicated. Like how about you have 2 polar equations, they intersect, how do you find the area in between and or the area outside one, inside the other one, those type of the problems here. So let's go ahead and start. And before we do it, the first thing is I just want to give you a very brief look how the equation was derived. So for example, if you want to find the areas here, right? So the area, bounded by, this the angles here from the angle from the A to B, between the angle A and the B, and then the different radius, you want to find the radius, you want to find the area R. So the basic approach is still very similar like what we did in the Riemann-Sum approaches here. That's what is the second one here is showing you. It's very similar like what we did in the Riemann-Sum. So basically you just divide this area into many small kind of like triangles. So basically we say, okay, so how do we do that? How do I approximate this like blue triangles here? So what we did here is basically is just let's go back to our basic geometries here. So if I have a sector of the circles, right? So in order to find the area of this sector, so we say is pi r square. So it's like the pi r squares, right? So it's 1/2 the r squared to the theta. So what is the theta here? Theta is radius, right? So it's a theta over 2. So because we are related to the pi r square, so that's why it's a theta over 2. And the r square is just the area. So that is how, from the area of the sector, we know from we learned in the geometry. So we say, oh, okay, so this Riemann-Sum, I can kind of approach this area by add up all those little kind of the triangle. So it's kind of the approximate to the sectors here. So it's 1/2. So what is this values here? The values of this, the height of these triangles will be what is f theta here, right? So then, because this is kind of like Riemann-Sum, you divide this, the interval become like small and smaller. So when you approach to the end, to the infinity, that has become the integration from the A to B, 1/2 f theta square, and the f theta is r, so it's 1/2 r squared here. All right, so this is just a very brief, like give you the idea why my area of the polar area is 1/2 r squared here. Okay, so now after we do this, now let's take a look. So these 2 problems, okay. Okay, so these 2 problems here. Okay, so these 2 problems here are the easiest one. So what is this? Why I say this is easy problems here. So these ones we're telling you here, if they already give you the, where is this angles to be, right? So they said, hey, this graph r equal to the e theta, and I want my, I want my theta is between the 3 pi over 4 to the 3 pi over 2. So this type of problem, they already give you the, the angle. So that's pretty easy. So you just say the areas here will be what? You just integrate from the given angle. So this is 3 pi over 4 to the 3 pi over 2 here. All right. And then the 1/2 r squared, right? 1/2 r squared d theta. So basically what you do here, so this is 3 pi over 4, then the 3 pi over 2, 1/2 r squared, so it's e the what? 2 theta, d theta here, right? And then you can just apply the regular integration. So what is 1/2 e theta? E the 2 theta is will just be 1/2, and then here is 2 e the 2 theta, right? Then you have upper bound is 3 pi over 2, and the lower bound is 3 pi over 4. You can just substitute. So the final answers here will be the 1/4 here, right? So will be the 1/4, and then here will just be the e, the what? 3 pi minus the e, the 3 pi over 2. Like I said, for this type of problem, it's pretty easy because they already give you the, give you the where the angles you want to be. So the same way is here for this graphs here, r is equal to the sine theta plus cosine theta. So you will say a is the same thing from 0 to pi, 1/2 r squared, right? So r squared is just the sine theta plus cosine theta square d theta here, right? So now in here, you might need to use a little bit like the trig identity. So this will be the sine square theta plus 2 sine theta cosine theta plus cosine square theta, right? D theta, that's right. Then the sine square plus cosine square, it will be, so this will be the 0 pi. And so sine theta plus cosine theta is 1, right? So it's just 1 plus 2 sine theta cosine theta. And then we also know the 2 cosine theta sine theta, these ones here become what? Sine 2 theta, right? That's just my basic trig identities here. Now I can, just integrate. So this is 1/2, and this will be the theta. Then what is minus, right? So the sine, your integration will become cosine. So it's a cosine 2 theta. And then you put the upper bound and the lower bound. And so what is you substitute, the final answer will be pi over 2. So like this is the first level type of the area problem. It's very simple. They give you the R, they give you the angle range. So you just directly plug it into the formulas here. Okay, now let's take a look at next levels here. Okay, next levels here. So they want you find the area of the shaded areas here. So like they want you find this shaded area. They also give you, this is the functions r squared to the equal to the sine 2 theta. So from our previous video, we know this is what? This is, we call this a figure 8, right? So this is a figure 8, the graph is here. So the first is here. So because the R is already given to us, as long as I know where is the angle. So let's take a look at the sine 2 thetas, right? So sine 2 theta. So that means the sine 2 theta. So I know the period will be what? The period will be like 2 pi over 2. So will be pi here. Okay, so remember we talk about we can use the Cartesians and try to, and try to do that. We did this graph, so we know when the theta equal to 0, right? So when the theta equal to 0, so from here to here, this top points here, right? So r squared equal to the sine 2 thetas here. So this is when this is a pi, what? This is a pi over 4, right? Because we know the sine, go to the pi over 2 is the 1, but this is 2 theta, so it's pi over 4. So from pi over 4 to the pi to the pi over 4 to pi over 2. So it will be this, right? So it will be this curves here. So I know this shaded area is defined by the theta is from the 0 to what? 0 to pi over 2 here. After we get that, then the area will be pretty easy. So this will be A is equal to 0 to the pi over 2. Then you can say 1/2 r squared d theta. Then this will be the 0 pi over 2, 1/2 r squared, right? So the r squared is already, so the pi over 2, so this will be the r squared. So the r squared will be, my r here is the r squared is sine 2 theta here. So since that they already give you r squared sine 2 theta, so this is basically I just do the sine 2 theta here, right? D theta. And then you can directly just integrating that. So the sine become cosine also. So it's 1/4 cosine 2 theta, right? Then you plug in the upper bound and the lower bound, and then the answers here will be 1/2. Okay, so this one is kind of pretty easy. It's a little bit harder than the first problem, but it's kind of still pretty easy because you can find the angle where is these regions here. Okay, let's take a look at this one here, right? This is the heart-shaped one. So it's like a little heart here. So these functions here is 4 plus 3 theta. Okay, so now let's take a look like we did before. All right, so let's take a look from here, you know, this curves here, right? So when theta equal to 0, right? So it get 4. So this point here, this is what? This is 4 zeros, right? Then you go all the way to here when the theta equal to pi over 2. So this is 7, right? So this is 7 and the pi over 2. So this area by this pink lines here is from the 0 to pi over 2 here. Okay, now let's take a look what is this area here. Okay, so this area, so when the theta is equal to the 3 pi over 2, then this is 1. 3 pi over 2, this is 1, right? So this is 1, the 3 pi over 2. All right, so be careful here. This one did not flip back because this is a positive r here. So then when the theta turns here, right? So for the 3 pi over 2 to the 2 pi, so this area, right? So this area by the green one is from the 3 pi over 2 to the 2 pi. Right? So one way you can do it, you can say, hey, I'm adding the pink area. So this is from 0 to pi over 2 and 1/2. So 1/2 the r squared d theta, right? Then plus, you can say this is the 3 pi over 2 to the 2 pi, 1/2 of the r squared d theta here. Well, of course, you can do that. Or we can do a different way. So the 3 pi over 2 is you swim from here all the way to here is 3 pi over 2. Or we can do this way here. We can say we can combine it to 1. So I'm still all the way integrated to pi over 2. But this is 3 pi over 2. You can also treat as you swing the clockwise. Right? So if we swing the clockwise, it's negative angle. So this is from the negative pi over 2 to the positive pi over 2. Then you will have 1/2 r squared. So r squared is 4 plus 3 sine theta squared d theta here. Okay, so now you can just do a lot of algebra So you can take the 1/2 out, and then this is negative pi over 2 to the pi over 2. Then you can do some algebra. So this will be the 16 plus 24 sine theta plus 9 sine square theta d theta, right? And then you can just, you can just take the integrations. So this will be 1/2. Then this is negative pi over 2. Okay, so the pi over 2. So in here I can do a little bit of. So for the 9 sine theta here, right? 9 sine square theta, I can say this is 9 times 1/2. And I use double angle cosine 2 thetas here, right? So I can do the double angles here. So now in here, I can just integrate. So this will be the 16 theta. So this is what is 24 cosine theta. And these terms here will be 2 over 9 minus 9, 2 over 9 cosine 2 thetas, right? So then you can say minus 9 over 2 theta. Then the cosine 2 theta, you can say in here, this will be the, okay, so this is plus, I'm sorry. So this is plus, and then you can say minus 4 over 9, right? So you can say the 4 over 9 sine 2 theta here, right? Then you put the upper bound and the lower bound. Now this problem is a little bit more tedious, but basically the idea is the same. Like I say, you can divide it into these two, and then you substitute a different bound, or you can just think about it. You swim the 3 pi over 2 is similar like you swim the negative pi over 2. See here. Then you plug in here, and so the final answers here will be 41 pi over 4. Okay, so for this problems here, we just need to be a little bit careful, right? So this one is a little bit harder than the previous one, and here you can say, you want to, separate it into 2 parts, or you can combine it with 1. Then you need to, from here, you need to use the double angle, right? And in order to be able to integrate. Okay, now the next one, so will be another level harder. So instead of give you, the graph, right? So the previous 2 examples here, they give you the graph. Now they give you equations here. So then let's say, hey, I want to find one loop of the curve. All right, one loop of the curve. That means the first thing, so what you need to do, you need to graph it, right? So this is 2 sine 5 theta. So remember from our previous video, we said when we try to graph it, maybe we can graph the Cartesian way, then we be able to get the idea what the graph looks. So the first thing here, because this is a 5 theta, so my period here will be what? It's 2 pi over 5. All right. So remember that we want to do the Cartesian first. Right, so the Cartesian will give us these ones here. So this is 2, this is negative 2. Okay, because the period is 5 pi over 2. So I know at this point is pi over 10. All right, and at this point is pi over 5. And this point here is 3 pi over 10. And this is 2 pi over 5. So remember, right? So we said the positive, negative things, right? So let's see here. Okay, so now let's do, oops. Okay, so now let's do my pole. So let's do a quick graph of the pole. So, right. All right, so remember, right? Okay, so when we in the previous, okay, so let's take a look at this curve. This is from 0 to pi over 10. Okay, 0 to pi over 10 is from, so the value is, the R value is from 0 to 2, right? So I know here, so this is, let's do a dotted line here. So it's pi over 2. So this red will corresponding to here. Right, so this point here is what? This point is the 2, then what? Pi over what? Pi over 10. Do you get that? All right, so now let's do here. So here, they will from here to pi over 10 to the pi over 5 here. Pi over 10 to the pi over 5. Okay, let's do another dot lines here, dot, 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 dot. Right? So I know this green one, start with here is 2, right? Then you go down to, when they reach the pi over 5, will be zeros here. I got one loop here. All right, so I got this loop here. All right, so this loop, so basically this loop is from where to where? This loop is generated from 0 to what? Pi over 5. You see here? Okay, so now I can find the area will be from the 0 to pi over 5. That's why for the previous video, we say if you use the Cartesian to help you to graph, it's extremely helpful, right? So then it's 1/2 r squared. So it's 2 the sine 5 theta to the square d theta here. All right. So then this will be, so we say here this is 0 pi over 5. So this will be 2 sine square 5 theta d theta. Every time if you see the square, what formula I'm using? I'm using double angles here, right? So this is 1/2. So this is 1 minus cosine. How many theta? 10 thetas here, right? D theta. So from here to here, we use what? A double angle again. Right? So you need to be very, very familiar with your trig identity. Okay, so this is 0 pi over 5. Okay, so now in here, after you do that, then I will get a theta minus 10 sine 10 theta. That's right. Now your upper bound and the lower bound is here. So now here, my answer will be pi over 5. Pretty neat, right? So that means this paddle of my rose will be pi over 5 here. All right, so this one is get one notch harder than the previous one, right? So previous one, they already did the graph for you. So that's pretty easy. So this one, you need to physically do the graph here. Okay, now let's take a look at the last ones here. This one is a little bit hard here. So we said R equal to the 1 plus 2 sine theta. Well, I want to find the inner loop here. All right, the inner loop here. Okay, so like we did before, the best way is what? Best way is try to do a Cartesians, right? So this is the sine theta. So it's typical 2 pi, right? So this is pi over 2, and this is pi. Okay, so this is pi, and this is 3 pi over 2, and this is 2 pi. Okay, so if you graph this graph here, so this graph will go to here. All right, so here's the 3, right? So this graph will start at 1, right? We'll go to here. All right, and it will go down here. Okay, so it will go down here. Okay, and then going down here and something like that. All right. Okay, so this is the one we did in our previous videos also, right? So now let's try to do the polar graph. After we do that, and then should be pretty easy for integrate. All right, so here, remember that, right? So we look at we look at where is the positive, right? So here, let's take a look. From 0 to pi over 2 here, right? From 0 to pi over 2 will be what? Is from 1, right? So that means I'm starting here. I'm starting 1 here, right? I'm starting 1, then go all the way to 3 here, right? So this will be go like this. Right, so this will be 3. So this point is here is 3 and pi over 2. Okay, okay. Now I'm starting going down to pi here. Okay, so when sine equal to pi, I'm hit the 1 again, right? So let me so from the 0 to pi, so basically I generate this one here, right? So this is right. So this is the pink ones here from pi. Then I know here. Okay, so now these terms here, right? So okay, so here from the pi to the this point here, this point will be the 7 pi over 6. And then this point here will be the 11 pi over 6 here. Okay, so from pi to 7 pi over 6. Okay, so this little lines here still is positive, right? So that's why this little line here will generate from here all the way to 0. Okay, all right. So now, okay, so now start from here. After 7 pi over 6 here. Okay, so look here. After 7 pi over 6, I'm start to getting the negative number. Okay, so when I get in the negative number, so also remember when we do this, we say let's do a kind of a dot line. It will help you. So this line here is when we reach all the way to 7 pi over 6. All right. And this is the dotted line. Okay. When we reach all the way to the 11 pi over 6. Okay. So now take a look here. When you are in these regions here, right? So because it's negative, so what do? We flip back, right? So this one's here, flip back to here, flip back to here, correct? So this point here will be the -1 to the 3 pi over 2, right? So this one is flip back here. So this is my golden ones here, flip back to here. And then my last ones here, let me use a good color. So my last one is the purple ones here. My last one is from here to here, right? So from here to here, just like we did in the previous video, this is negative. So the graph over here is what? Is a flip over to here. So I want to find, so the last ones here, this one is, okay, so the last ones for this part, little part, right, from the 11 pi over 6, this little part become positive again, so go like this. So complete the whole curves here. So you can see by the color coding, how do I do each ones, right? So since they want us to find this inner circle, all right, so they want to find the inner circle. So the area will just be what? Okay, so it's will be from 7 pi over 6 to the 11 pi over 6, 1/2 r squared. So this is the 7 pi over 6 This is 11 pi over 6, 1/2 r squared. You just do the 1 plus 2 sine theta squared, d theta here. Okay, so then you can just do a simple trig identity. So you will say the 1/2. So this is a 7 pi over 6, and it's 11 pi over 6, right? Then here you will just 1 plus 4 sine theta plus 4 sine square theta, d theta. So one more time, this is a sine square. So what I need to do here? I need to use the double angles here, right? So it's always the same thing. So this is 4 sine theta will be 4 times 1/2, 1 minus cosine 2 theta. So now we changed everything in a form I will be able to, integrate. So finally, after I integrate, this answer will be, the theta minus 4 cosine theta plus 2 theta minus sine 2 theta. And I will have like the 7 pi over 6. Okay, so I will have a 7 pi over, okay. So I will have a 7 pi over 6 and to the 11 pi over 6. And so my answer will be just be the 2, the pi minus square root of the 3 over 2 is here. So that's it, right? So that they want to find from the inner one. So it's from the 7 pi over 6 and all the way to the 11 pi over 6 here. All right, so I hope that my algebra is correct here. Okay, but you get the ideas, right? So when you do this one is even harder. So the first you need to graph. Remember, use a Cartesian to help you to graph, so you know exactly where is each, it's each areas here. Then you just use your trig integration and to integrate that. All right, that's it. And I hope this helped. And our second video for this part number 4 is going to be how about if I have two polar curves here, how to find the area in between those things. So it's still the same. Basically we just need to find where is the angle and where they intersect here. All right, that's it. And I hope that this will help you to do how to find the area by the polar curves here. All right. Okay, bye. Talk to you in our next videos here. Okay, bye-bye.